All right, welcome back. We are going to be working through Pythagorean Theorem very quickly today and then looking at the application of the distance formula. To start, I want you to just go ahead and pause the video for a moment and work through these two Pythagorean Theorem problems. And when you come back, we will go over them as a group. So looking at this first problem here, we first label our hypotenuse as C, so across from the right angle. The other two will be A and B. We will now use our A squared plus B squared to solve out for C. A is 6 squared plus B, which is 9 squared, and all equals C squared. 6 squared is 36. 9 squared is 81. Together they still equal C squared. We will now add the two together. 36 plus 81 and get 117 equals C squared. We'll take the square root of both sides and we get 10.81. When we round this to our nearest tenth, we'll get 10.8. The next problem we look at, we label our hypotenuse, so we go across from our right angle, and we label our two sides. A and B. We now put them into our formula. 7 squared plus 10 squared equals C squared. 7 squared is 49. Plus 10 squared is 100. C squared, still there. We add these two together. We get 149 equals C squared. We now take the square root of both sides. When we take the square root of both sides, we get 12.20. So C would round to 12.2. We are now going to look at the Pythagorean theorem on a coordinate grid and how to work through that. The first thing we're going to do is create our right triangle. And the way that we create a right triangle is we draw a horizontal line directly across from one point, and we just draw it down. We take our second point and we draw a vertical line. Once we have these vertical lines and these horizontal lines, we will notice that they intersect. They intersect at a perfect horizontal and vertical intersection, which will make them perpendicular. So they will have a right angle right here where I put the green square. And now what we will do is count our sides for A. 1, 2, 3. And our side for B. 1, 2, 3, 4. We now have a 3 and a 4 for A and B. If we notice, our right angle is right here, so across from the right angle is our C. Now we will work through this using our Pythagorean theorem. So we will do 3 squared plus 4 squared equals C squared. We get 9 plus 16 equals C squared. These two added together gives us 25 equals C squared. We take the square root of both and we get C equals 5. Go ahead and give these next few a try following those same rules. And pause your video, work through these 3 problems, and when we come back, When you come back, we will go over them. So work through them first, and then we will work as a class on the board. I will show you how to work through them. All right, so let's look at this first one here. It does not matter which point we start at, as long as we draw our lines only horizontal and only vertical. I've now created a right triangle here. I have a red horizontal, 1, 2, 3. So A is 3, and 1, 2, 3, 4, 5. 5 for the blue, which is our B. So I now have 3 squared plus 5 squared equals C squared. 3 squared is 9, plus 25, because 5 squared is 25. It all still equals C squared. 25 plus 9 will give us 34, equals C squared. We'll take the square root of both sides, and when we take the square root of 34, we get 5.83, so C equals 5.8. As we look at this second one, again, like I said, it does not matter which point you start at when you are drawing horizontal and vertical, as long as you stay horizontal and vertical. And again, I can draw that line all the way over, and then I can draw this line all the way down. And I notice that they cross, and where they cross is where our right triangle actually exists. So this was extra line here and here. Ooh, too far. And now I count my horizontal line. 1, 2, 3, 4, 5. 5. And the vertical. 1, 2, 3, 4, 5, 6, 7, 7. Now it's very nice to actually use those little bumps, because if I'm getting confused and I'm not counting correctly, I can always look at the bumps and tell how many bumps I have. 1, 2, 1, 2, 3, 4, 5. 5 bumps, 5 squares. Same thing with the other side. 1, 2, 3, 4, 5, 6, 7. 7 bumps, 7 squares, 7. So now I will put these together, and I will do 5 squared plus 7 squared equals C squared. 5 squared is 25, plus 7 squared is 49. They're still equaling C squared. I add them together, and I get 74 equals C squared. I will now square root 74 and square root C squared, and I end up with C equals 8.60, so it rounds to 8.6. Our last example here, again, draw my horizontal, draw my vertical, count the bumps. 1, 2, 3, 4, 4. 1, 2, 3, 4, 5, 5. Put them together. 4 squared plus 5 squared equals C squared. 4 squared is 16. 5 squared is 25. Still C squared. 16 plus 25 gives us 41 equals C squared. We take the square root of both sides. We end up with C equals 6.40, so it rounds to 6.4. Alright, we're going to now look into the distance formula. We're going to start with the distance formula on a coordinate grid. So it's going to look very similar. And we can always use the Pythagorean theorem when we are provided a grid to check our work using the distance formula. So looking here, it says the distance formula uses the Pythagorean theorem. We use the Pythagorean theorem to solve for the distance between 2 points on a coordinate plane. And our first step is going to be finding our 2 endpoints. We have one right here that I've highlighted in red and one up here in blue. We will find those 2 points and we will label them point 1 and point 2. Point 1 is in red. It is -6 over and -5 down. So -6, -5. And point 2 is -2 over and 5 up. And with that, we are going to label now our x1, y1 with our point 1, which is our red point, x1, y1. Let's break that down even further. Let's do it right here. x1 equals -6. y1 equals -5. x2 equals -2. And y2 equals 5. Now that I have all of these different values, I'm going to substitute them into our distance formula. We have distance equals the square root of x2, which is -2, minus x1, which is -6, plus y2, which is 5, minus y1, which is -5 squared. And now we're going to move on to the next page and continue this. So we're going to rewrite this on the next page. Give me just a second to kind of cheat here. I'm going to copy this all. Sorry, I'm having a technical difficulty here. All right. And now that we are here, we are going to actually work through these problems. And we're going to do the subtraction or addition first. So we get, because they're inside of the parentheses, we are going to work through that. When I do -2 minus a -6, it actually becomes a positive. So -2 plus 6 gives me +4 squared, plus 5 minus -5 is actually going to change to a plus as well. When I get 5 plus 5, I'm going to get 10 squared. So our next step is going to be squaring those values. When I square 4, I'm going to end up with the distance equals 4 squared, which is 16, plus 10 squared, which is 100. I'm going to add the new values together, and something we need to remember is that at this point, both of our numbers should be positive. If our values are negative, we did not include our parentheses up here. We need to make sure that we use parentheses in case our number is negative, because it is a 4 times a 4. If this had been negative, it would have been negative 4 times negative 4, which would still give us a positive. So now we do 16 plus 100 gives us the distance equals 116. We will take the square root of that, and we get distance equals 10.77, so this rounds to 10.8. And what we can do is we can go back through and double check this the same way we did here. 1, 2, 3, 4. I made my vertical and horizontal lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Those numbers will be the same as this step here. If you notice, I have a 4, and I got a 4. I had a 10, and I have a 10. Now, if they are negative numbers at this step, that is okay. Again, because once we hit the positive, they become once we hit the square, they become a positive. Make sure that as we are working through these problems that we follow the directions, and we are aware of what the direction wants us to leave our final answer to. Does it want it to leave it in a radical? Does it want us to round to the 10th, the 100th, the 1000th? We make sure that we round to what our directions tell us to do. So go ahead and work through these next few. I'll give you a moment. Go ahead and pause the video. Work through these using the distance formula, finding the 2 points, labeling one of them point 1, labeling the second point 2, and working through that substitution of x1, y1, x2, y2. All right, so now we will start with this first problem. We will find our 2 points. Use a different color there. So our first point is here at -3, 1. And since that is our first point, I will call it P1 right off the bat. And our second point is up here, and that is 2 over and 5 up, and that gets P2. P1 gets x1, y1. P2 gets x2, y2. So that makes x1 -3, y1 equals 1, x2 equals 2, and y2 equals 5. Now that we have these values, we can put them into that distance formula. And I did not rewrite it on this page, so if you need it, I will write it right up here. It is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I will now substitute in those values for the distance. We have distance equals the square root of x2, which is 2, minus x1, which is negative 3, and we square it, plus y2, which is 5, minus y1, which is 1. We square it. We get 2 minus negative 3, which these become a positive. So 2 plus 3 gives us distance equals 5 squared, plus 5 minus 1 gives us 4 squared. 5 squared is 25. Plus 4 squared is 16. When we add these two together, we get 41. We take the square root, and we get 6.40, so it rounds to 6.4. Scroll back up and look at our second problem. The first point is here at 1, 5. And point 2 is down here at 5, negative 4. Means that x1 equals 1, y1 equals 5, x2 equals 5, and y2 equals negative 4. We will plug these into our formula. The distance equals the square root of y2, which is x2, which is 5, minus x1, which is 1, squared, plus y2, which is negative 4, minus y1, which is 5, and squared. We get the distance equals square root of 5 minus 1, which is 4 squared, plus negative 4 minus 5 gives us negative 9. This is where keeping those parentheses counts. If I did not have a parentheses on negative 9 squared, I would end up with a negative 81 instead of a positive 81, and it must be positive at this next step. So d equals the square root of 16 plus 81, and 16 plus 81 equals 97. So we get the distance equals square root of 97, and the distance then equals 9.84 when we take the square root of 97, so we'll stay at 9.8. Scroll back up, take a look at our last problem. We have point 1 right here at negative 3, 5, and point 2 right here at 3, 1. Which that makes x1 negative 3. It makes y1 5. It makes x2 3. And it makes y2 1. And so now we are going to work through these using our distance formula. The distance equals the square root of x2, which is 3, minus x1, which is negative 3 squared, plus y2, which is 1, y2, which is 1, minus y1, which is 5. So now we have the distance equals 3 minus negative 3. This is going to become a positive, actually. 3 plus 3 gives me the square root of 6 squared, plus 1 minus 5 gives me negative 4 squared. This next step needs to be positive, so I make sure I leave those parentheses there when I put each of these in my calculator. And I get 36 plus 16. I get 52. D equals the square root of 52. And D equals 7.21, so we'll stay at 7.2. And when we look at all three of these, if I wanted to go back through, I can make those right triangles. 1, 2, 3, 4, 5, 5, 1, 2, 3, 4, 4. I needed 5 and 4. 1, 2, 3, 4. 1, 2, 3, 4. One, 2, 3, 4, 5, 6, 7, 8, 9. 9. I had 4 and 9. I know that that one is a negative 9, but for this situation, it is going to result in a positive square, which is the same as 9 squared. This last one here, draw my horizontal, draw my vertical, I end up with a right angle, and I get 1, 2, 3, 4, 5, 6. I get 1, 2, 3, 4. I get 4 and 6. I had 4 and 6. 6 and 4. And we can use the distance formula without a coordinate plane. The distance formula without a coordinate plane. And the steps are going to be the same, except the endpoints are already given. The endpoints are given. And so looking at this, we're going to follow very similar steps to what we just finished doing, except that instead of having a graph to be able to check our work using the Pythagorean theorem, we no longer would have that available. So looking here, it says label the points as point 1 and point 2. We have an example right here. We're going to work through that example right here on the side and through the next page. And so I have 2 points. I'm going to label point 1 as 4, 6. I'm going to label point 2 as negative 3, 9. And point 1 gets my x1, y1. So x1 equals 4. y1 equals 6. x2 equals negative 3. And y2 equals 9. I'm going to now substitute those values into the distance formula. And I get distance equals the square root of x2, which was negative 3, minus x1, which is 4, plus y2, which is 9, minus y1, which is 6, now I'm going to work through this problem. The distance, I'm going to switch over to the next page. We're going to follow our PEMDAS. We had distance equals the square root of -3 minus 4 minus -4, sorry. Nope, -3 minus 4 squared plus 9 minus 6 squared. 9 minus 6 squared. I'm going to do those subtraction problems. The distance equals -3 minus 4 is going to give me -7 squared. Plus 9 minus 6 is going to give me 3 squared. Again, I'm keeping the parentheses so that when I square these values, I get the accurate number. And when I square -7 on step 6, I'm going to get the distance equals 49 plus 9. I'm going to add those two values together. I get distance equals 58, square root of 58, sorry. I'm going to now take the square root of 58, and I get the distance equals 7.61, so 7.6. Remember again to follow the directions on the assignment or question given, and look for what the directions tell you to leave your final answer in, or what they want you to round it to. Very important. Please try these practice problems and round to the nearest 10th. We will go over these in person, so please complete these and have them ready to go over in class. If you need to, you can always draw yourself a coordinate grid to help check using the Pythagorean theorem. Next lesson will be on the midpoint, and from the midpoint we will go on to the slope. All right, see you guys next time.